Hey there. All right, it's today's Wednesday, I think. It's been a couple days. I had an unexpected sink failure, so the faucet in my kitchen broke, was stuck on, so I had to spend my free time fixing that. But while I was working on that, something I ordered from Arturo came in. So I had this little BlackBerry 10 keyboard with a little module. It's got a little AT-SAMD, I think, on the back of it. AT-SAMD 20, I think. But basically, it's a little I2C breakout board for the keyboard. So the microcontroller on there manages the keyboard, and then you just talk to it. So I'm going to write a little Rust driver for this, or I'm going to attempt to write a little Rust driver for this. First things first. Well, let me pull up, while I'm off looking up documentation, let me go ahead and pull up the product page so y'all can see what I'm talking about. I'll plug it. Arturo also makes awesome stuff, so I hope he puts more stuff up on Tindy, because he has some pretty awesome stuff. So this is Arturo. You should follow him on Twitter. I think he streams sometimes too. But yeah, he's working on a bunch of cool stuff that I've been waiting on. I also ordered some of these RGB color OLED PMODs, little tiny itty bitty like 1-inch kind of things. I don't know if I have anything that's useful for scale. I have an NR52 dongle, so you can kind of see versus a USB connector, something like that. My hand's over it. I can't. But yeah, it's a pretty tiny little board. I might make like a little game thing out of that. We'll see. That's possibly a much larger. Oh, this is interesting. Oh, hold on a second. I'm probably gonna confuse the heck out of my screen because I'm in 4K on my main screen, which means the resolution's wrong. Let's see if I can do this without confusing OBS. We will see. Okay, how does OBS look? Okay, OBS seems to have no. Okay, now it seems to have figured it out. Okay, cool. Thanks, OBS. Yeah. So this is what I'm checking out. The other thing that I'm going to do is I'm going to use my Decawave board just because I have header pins wired up on it already. But I have to go look up the datasheet. I'm sure I've downloaded this about 47 times, but Decawave DBM 1001 schematic. But yeah, hey to everyone who's watching. I'll keep an eye on the matrix room. I should say. Decawave download. Don't show it in a browser. Let's get, Alt Shift 6. Alt Shift 6. So this is the schematic. Oh, you know what? I always do this. I get the DWM 1001. I need the DWM 1001 dev. Because I need the dev board. Because what? This is a really cool board with cool pinouts, but they haven't labeled any of the actually I think I will need both of these, so it's good that I pulled this one up. DWM 1001 dev schematic 5. Yeah, I should just go search through my downloads. That's going to be too small, but we'll get rid of this. So I've got what? I've got my data sheets. I think that should be all I need. Then I need to make a little... project from scratch. So let me... what's going to be the best way to do this? I know what I'm going to do. I'm going to... let's do this over in 5. So let's CP minus R stream to tiny NRF52. Let's call this BB Q10. That's going to be BB key. So I don't need the Git repo in here. Clean. Let's update my dependencies. Cortex MRT. This pulls in the DWM 1001 crate. I actually don't want this at all. I want the NRF. What is it called now? NRF HAL Rust. NRF RS. NRF HAL. They released some new versions, and I want the 832 HAL. So I guess it's just NRF dependencies.nrf 832 HAL version equals 0.10. Features. I want the RT feature for Cortex MRT, and I want the XXAA package. So this tells me how much RAM I have. I think that's all I need. And let's change this to BB key. And this is gonna complain because Multiple memory configuration features specified. I think it defaults to XXAB, which is the smaller one, but like no one ever uses the XXAB. But to be fair, it keeps people from accidentally using more RAM than they have. Source main. I'm not going to use the GWM 1001. Let's just use the HAL. The reason I'm not using this is because it hasn't been updated yet for the new NRF52 HAL, and I want to use the new NRF52 HAL, but these are, you know, problems. I think the other thing is I did want to look at the build. Yeah, stuff in here is not going to be. I probably shouldn't have copied from this because this is not going to get me much. Loop. Continue. Use Cortex-M. Why am I breakpointing? What did I do in a breakpoint? Oh, that's right. That was from the other day. Board is not in scope. Yeah, okay. So let's go look at the... Boop, boop, boop. Let's get a web browser up here. docs.rs NRF 52832 HAL. Where's my peripherals? DWM 1001 source lib. So I'm still using this, and I'm gonna want to steal some things. Let's see. Peripherals. That's what it's called. It's called target. Let equals target peripherals take. Right. This is a result. Dot. Okay. Or oops. That's not going to be board. Let's see. So I've got my peripherals now, and then I want to go look over here because I'm going to want a USB UART. Let's just steal this function entirely. USB UART config. I think that's, I don't actually need the config. I'm just going to hard code it. Well, let's just, you know what? Prifs dot UART0 dot constrain. What is it called? Let UART equal. Oh, is it not? It's not constraint anymore. That's right. It's gonna be UART new. That's actually what changed. UART new. Do you know what it is, Rust Analyzer? No, that's probably not in the prelude. So UART new. What do you need? You need the UART. So you need U. You need pins. TXT pin needs to be prifs dot, was it P0? I need to do a split, don't I? Let pins equals what is the pins thing now? GPIO. Why is GPIO not in the... How do I get one of you? It's not an extension trait anymore. I don't remember what the pin split is. Okay, you know what, we're gonna go look at... I'm just gonna look at the code, because how common source GPIO. There's got to be like a split or something. New parts, new GPIO PX. Yeah, struct parts. It's called parts. Yeah, but don't you have a new? Okay, I was just blind. GPIO P0 parts. Prifs dot P0. Right, and then now I can look at this, and TX is pins dot P005, and RXD is going to be pins dot P0. 11. And yeah, we still don't need CTS and RTS. And then parity baud rate, but we re-export those, don't we? In URD. We give them a better name. Pubuse baud rate. Okay, use URD. Okay. URD parity excluded 8N. URD baud rate. Yeah, 115200 is fine because we saw it can cause problems if you go faster than that. So now I have my UART. Probably needs to be a MUT UART. What are you complaining about? Level high. GPIO? Am I not pulling in the GPIO module? Ah. Cool. So let's plug you in and make sure I at least have running code. What are you on? No, not on port. Regular port. So how's everyone doing tonight? Chat seems quiet, but we got a couple people watching, so that's good. Anyone working on fun projects? Or are you just here to hear me talk? Okay, while we're doing that, while that's building, I'm gonna go over here because the thing that I need to do is I need to figure out what pins I have. So this is the connector, our pi header. And I can never remember what pins are brought out here. So the pins that are brought out that I can use as GPIOs, let's use, which ones are you? I've done a weird connection thing here. So top right, these should both be 5 volt RPi ground. It's actually the left row I probably want. So let's follow SDA, RPi, and SCL. So SDA, left row, skip, SDA, RPi, and SCL, RPi, and then I'm also going to probably need 3.3 volts. Does this provide 3 volts on the header? I can't remember. I should go get my multimeter. Before I plug anything in, I should go get my multimeter. Did I bring it in here or is it in the other room? It's probably in the other room. So I will be right back. I'm going to go get a multimeter. Alright, and unmute myself. So I have a multimeter now, so let me make sure that I am aligning myself correctly and these aren't out of order. Also, hey Yosh, I just saw you're in the stream. Hopefully we can get some successful embedded development today. So I have, this is going to be a little off camera, but I'm going to check that my voltages are right. So if I am right, it should be 3 volts on the top pin. And then SDA, SCL, nothing ground. SDA, SCL, nothing ground. Am I getting positive 3 volts there? I'm not. I'm getting like 0.8 volts, which is a weird number of volts to be getting. I really hope I don't need to pin out. Ground should be the bottom one. Well, I know this big hook here is ground, so that's good. 2 volts on that. That's a solid looking 3 volts. Okay, so this one should be ground. Yeah, it's a solid 0 volts. So what about 4 up from the bottom on the left? Am I gonna have to solder on another header to get 3 volts? Cause I thought I'd powered stuff off of these boards before, but maybe not. This is not a particularly yeah, you're giving me not 3 volts. That looks like not connected. Yet none of those go to... None of those go anywhere. Okay, where do I have 3 volts on here? You have 3 volts. You have like 4 volts. It's gonna turn into a soldering episode. Where on this board is 3 volts? Do I have another board with headers broken out? You know what I can use? I can use the 832 dev kit. Okay, so yeah, none of the... I could have sworn that 3 volts was broken out on this header. Are they breaking out V-LiPo bat? I don't want that. I don't want 3V4 Seger. I could have sworn there was just like a 3v3 pin, but maybe I've only done external stuff here. Jumper 4 should be 3v3, J4. You? Okay, you do have 3 volts there. Did I plug that hole with something? Can I get a pin in there? If I can get a pin in there, then I will solder that very quickly, because I do have my soldering iron out. But if I cannot get a pin in there, because that VIA looks like it has solder in it already, then I'm just going to go get my other dev board, but that makes me less excited. There's a pin with a stuff in it. No, is that really what I can do is I have another one of these, and this one doesn't have, but I don't have headers on that one. Ugh. Okay, I'm gonna go get another dev board. Okay, now I have an RF52832 dev kit because that has all the pins, including the power pins, broken out. And I'm not really doing anything with radios right now, so it doesn't matter if I use one board or the other. Yeah, I guess I've only done external communication where I powered it through something 5 volts. Yash is asking if you mess up the software, can you damage any devices? You can. It's not as easy as you might think, especially if you're just working with stuff on the chip. It's usually if you have something more powerful connected, like if you have a motor or something that's like connecting higher voltage or more current or something like that, then it's sort of possible. Yeah, sorry. J-Link. The only thing I sort of remember these boards having a weird like I2C expander where you had to like short a pin to actually get the pins to go out, but we'll fiddle with that. And now I have to figure out a different set of schematics, because now I need NRF52832 DK schematic, because I want to know what pins go to PCA 040 or 52 development kit. So let's get rid of these because I'm not using this board anymore. Downloads, firmware files, hardware files. I have so many things in my downloads folder. I have too many things. Antenna schematic layout 6. This is the fun of embedded development. UART. I'm pretty sure these pin out a UART to the interface MCU. This is the main MCU, probably NRF radio interface MCU. There's going to be one of these that go to RxD CTS. Yeah, it's got this weird signal mux thing going on. Tell you what, don't we have a NRF HAL boards? Didn't we write NRF 52 day kit? Yes, we did. Does it have the UART and stuff? Hey, look at that. TXD P006 and RxD is 08, and looks like we even have some so let's see if we can't get a serial port going. Okay, so now we've got a GDB server going, and let's in here, let's just UR dot write ACM0 115-200. Let's make this readable. Boop, boop, boop. Well, I didn't see any output. UR dot right. Well, it got there. Are those the right pins? Let's go look at what those pins do. Because they were what? They were 6 and 8. Pin 6 and 8. There's like a detect or something that you have to tie to ground. What is detect on this? Yeah, I think it's ground. So I need a cable. So if I put ground detect to ground, and then we do a mon reset. No. Okay. Well, let's figure out what's wrong with our console. Well, maybe it's not 115-200. Maybe. Oh, is. Huh. Dev TTY ACM0. Control A, quit. One 200. Yeah, mon reset. Yeah, okay. Boop, boop, boop. Where's my hello? I want my hello. This is not what I want to be doing. I want to be sending data. CTS. Yeah. TXD 06. TXD06. RXD08. Okay, what if we none these out? What's up with my... Oh. Apparently there's a firmware update available. What is going on with GDB? Now GDB's not cooperating either. Error in sourced file. Target remote 2331. You're on port 2331. Yeah. Okay, tell you what, let's... No emulators connected via... Is this shield detect also preventing the debugger from attaching? Because that'd be really annoying. What is going... Normally I'm not futzing with my tools so much. You are plugged in. This is just an hour of me futzing with my tools. I'm going to be pretty bummed. If this continues being a butt, then I'm just gonna give up on the NR52 and I'm gonna go pick up an STM-F0 I have sitting somewhere, because I've got those, and those generally have not been butts to me lately. Okay. Well, no serial, but at least it's running. Yeah, now you'll load. Huh. Let's do. Okay, and here let's also get a delay going. going to copy and paste some more code. And we're going to see if we can get at least something going. We need what? Timer. New prifs dot timer 0. And then I'm gonna want probably the delay trait. That's probably in delay ms 500.ms there's trait for this. Oh, right. Outthinking myself here. Let's go find our schematic and let me find an LED. And let me find LED 4 is connected to SB5. B5. LED. Yeah, this has that weird LED thing going on. LED pin 17, 18, 19, 20. 17, 18, 19, 20. These 17, 18, 19, 20. Okay, let's at least get a let's at least figure out what's up with cannot borrow as mutable. Save. Helps if you save. Okay, it's not blinking, but if I do that detect thing, put it on ground. I've got no blinky lights. This is just a cursed board. Actually, no, I don't actually want the ground detect for this because I do actually want to use the onboard LEDs, but I'm getting nothing out of this. This is not my day for dev boards. I should be getting like a 1 hertz blinky light in here. What is going on? Pin 016. Do I have LEDs in here? Oh, interesting. Oh no, that's the NRF. How? Dead kit. LED. 17. Oh, am I just off by 1? 17. Right. If I look at chat, there's probably people yelling at me. Oh, there we go. Okay. I am at least on 1 level successful. Okay. Well, okay, so that's my blinky LED. How do I get my console working? Because I should have a console here. I know what's up. This is going to throw an error because this is not from RAM. Hello, I'm starting to wake up. The NRF52 doesn't let you DMA out of Flash, and when you have a constant string, it's going to be stored in the static section in Flash. So let mut buff equals 1, 2, 3, 4, 5, 6, 7, 8 equals 0 U8 0 U8 8 buff dot copy from slice Okay, yes, okay. Collection of errors. Okay, we are off to the races now. Only like an hour in. Cool, cool, cool. Okay, I actually am pretty happy. Okay, so I have a working board, I have blinking LEDs, and I have a console. This is what we need. And what I'm going to do also in ZHRC down at the bottom, there's going to be Rust C wrapper. No. Because I was using SC cache, and I think that was causing my problems. Cargo build release. Okay, so we're gonna. Okay, that is all done. Okay, cool. Oh. Yeah, Rust C wrapper, right? Yeah, okay, cool. So we're going to start that. And while that's running, we're going to finally look at the actual docs for the BlackBerry keyboard. Okay. Okay, so now we're getting to the actual keyboard. So it's an I2C device. So the important thing is that the default is OX1F. So that's the address. And the firmware version is 1 and it has 1 byte. So let's see if we can say hello to this device. So while this is building, let's go off here and pull some more stuff in. So we're going to need twim and twim probably. And what pins do I have? I don't honestly know what we are and are not using. But let's go find some stuff on that data sheet that's not connected up to anything. So these ones are probably good ones. Let's see, 11, 12, where's 11, 12 and all them? Sure. Let's do, because what does this have? This has SDA, SCL, 3v3, and an interrupt. So yeah, let's do that. We're going to use 11, 12, and 13. So keyboard 11 is going to be SCL, or what is it? Yeah, 12 is going to be SDA, and 13 is going to be int. Twim new parifs dot twim 1. We're going to use 1. I can't remember if URD and twim share an engine, but just in case, we'll make sure we're not using that. And then this is going to want twim pins. What are the pins? What did I say? SCL is going to be pins.p011 dot into what did you want? SCL input floating into floating input dot degrade. SDA is, what do you want? SDA input floating also. Okay, pins dot p0. This is where I might actually want that ground detect, and it means my LED is probably going to stop working, but that's okay. Into floating input, because we have our console now, so I'm happy. What else do you need? You need frequency. Twim frequency. Sure, 100's fine. So now we have a twim, and I probably want some formatting here, but that's okay. Well, let's just say twim dots. I'm probably going to need to pull write read. Address is going to be OX1F. Bytes. Oh, I just need a read, don't I? This isn't the Adafruit board that has its own weird protocol. We just want to read OX1F is the address, and the buffer 0U8, and we just want, well, let's give 128, and then I want if let okay. Let's twim.read. So let's should probably. I just needed something. Cargo run. All right, it's gonna block forever because I haven't actually wired the thing up yet. So good. Now let's wire it up. So what do I need? I need 5 connectors here. Let's see if I can't find. I have a fresh sheet. No, these will work. Okay, -1. Connect these 4. Ugh. Okay, yeah, these are tight fits. And I managed to make ground green, which is good. 3v3 is yellow, which is totally nonsensical, but I'm wiring it up with some external cables. So let's pin this out correctly. So most important, we need ground. So let's see, I've got my digital pins over here. Let's just run one big wire across the board, and it's, like I said, it's probably going to make me do that ground sense thing. Okay, green is ground. Let's take the ground over here. Yellow is 3v3. We'll wait on that. Blue is SDA, which is 12. Purple is SCL. Yes, purple is SCL, which is 11. And interrupt is going to be gray, which is wired to pin 13. And 3v3 is going to be VDD. Oh, we got a backlight. So the device is lit up. So I didn't damage the, I must not have damaged the ribbon cable too much because it's decided to come up with a backlight. What do I need to do? Now I probably need my ground detect wire. And connect you to ground, and my LED went away, which is good. Well, it got something back, so that's good. So let's get some formatting up in here. Do I have heapless in here? I do. Let mut sbuff equals string new I don't know, let's give it some space. sbuff dot clear. Right. O2X. to 0. Can't find, probably need the right trait. What is it? Core format. Use core format right. Expected slice. Asbuff.as stir.as bytes. We got 0. That's, I suppose, possible. I don't suppose you're watching, Arturo, are you? Let's go look at the docs. So, oh, right. Okay. Yeah. Never mind. Firmware. It is a write then read. Equals write read. Because we have to give it the address. Equals hex 1. Hex 1. Interesting. Now it's throwing errors. Let's see, what would cause it to address 1. Let's move you over to desktop 5. Protocol uses I2C. The default is hex 1F because write read takes the address, the bytes, and the buffer. Okay. Well, let's go look at his Arduino library and see what his Arduino library does. Begin transmission, write, reg reset. Okay, well, I guess. Read register 8. Begin transmission, write, end transmission. Okay, so it does want 2 separate transactions. I thought write, then read. Write, then read data without triggering a stop condition. Okay, no, I do want a stop condition. So, fun Wow. Twim dot write ox1f. I don't know who started doing this. The Adafruit devices do this too, and it's really sort of annoying, where you have to write to them. And then you have to read from them in 2 separate transactions. And the Adafruit stuff even says that you should like delay some time. Arturo doesn't seem to be doing that, so that's good. But dot read it's just like an I2C style that's sort of annoying. But the code's probably easier. Okay, now I'm getting 0 again. Let me... Easier version just 0? What else can I read? There's probably a status register in here. Let me find some data that isn't 0. So the config registration, so let's do 2, because this should be overflow int key int use mods. So it should have some non-zero values in there for me. So if I write 2, let me actually turn this into an unwrap. Oh, interesting. Did you panic? Unwrap. DMA buffer not in memory. Oh, I did it again. Write, then read. Yeah. Yep, I did it again. Buff. Buff 0 equals ox02 buff dot 1. So that's my write, and my read's going to go to buff 2. That's good. Got 92. Okay. That's a value. Now if I go back to 1. Ah, okay. So now we've got some... I guess it's version 02. First nibble contains the major version and the second okay, do you have a version in here? Oh, there's going to be a lot of things called version in this. Where does version come from? Reg.h. Let's go look for where you talk about this variable verval. version major. Okay. Version major 02. Cool. So we actually got version 02. So this is actually working. Cool. I'm going to take a quick break. I'm going to come back and try and get some more going. So see you shortly. Okay, let's write some actual code now. So first thing I'm going to do is I'm going to make a little helper function that um, does a command. So let's just fun. I want to keep calling it BBQ because it's the BB Q10, but that screws me up with the like my library BBQ. So let's just call this Q10 command, which is going to take, well, twim, the type's going to be wrong. That's okay. Right is going to be, let's see, red is going to be a U8, and read is going to be an ANMUT. U8, that's fine. And this is going to be a result, usize, whatever for now. So let's call Q10 command with our twim, which is going to be an ANMUT twim OX01 ANMUT buff 2.1. And it's going to tell me, this is probably impossible for you to read. This is going to be an ANMUT twim target twim1, I think. Yep. Okay, so actually, you know what? Let's return so this is going to be twim.write. I don't know, let's make mut buff. Twim.write. I thought we had auto copy. Oh, for the embedded HAL traits, we have auto copy turned on, but we don't have that turned on for the direct. I should switch over to use embedded HAL traits because that would make porting this later easier. But twim write OX1F. And then I'm going to do twim.read OX1F read let's see, this is going to be and these buffers have the same lifetime. Beep beep boop. Expected. Yep. I probably didn't need the lifetimes. It probably could figure them out, but I helped it. Version if let OK resp got what is the format? I think that's the syntax for it. Version, and then let's read the config. What was it, 2? Version, or config, excuse me. Config. I keep getting this weird sourced error. I haven't seen that before. Let me cargo toml. I have incremental turned off. Okay. So let's make a little drain FIFO. I want to check the status register. 04. Let's see how many items are in there. So there's 0 in there, but if I start pressing some buttons, we start to get some data. So I guess 2.0 means that it's full. What does the status mean? 2.0. As well as the modified keys, 0 through 4. So only the bottom should be the number of items in the FIFO. I wonder if is numlock on at the moment. So if I do I don't know how to turn numlock on. 2.0 should mean key numlock is on at the moment. How do you turn numlock on? Help, I've never owned a BlackBerry before. Okay, let's implement the reset command. Firmware version. Chip reset register. Reading or writing this register will call a software reset of the chip. Okay, let's do that. Let's see, and let's do the if read.is empty, then we'll do the read. This is not a very good interface, but it will do for prototyping. And what do I need? I need 8. Okay. So now if I start pressing keys, I wonder if that's just an overflow. Like, Arturo, I wonder if that's just overflowing the... Or it's more than 4 bits? I don't know. Okay, well. I don't know, let's find out what happens when we... While let OK response equals Q10 command and my twim, what's my FIFO is 9. And my buff, I'll give it 2 bytes. Sure. Okay. It's just gonna give me 0, 0. So let's do let's do a loop. If this is okay, and if, I don't know, let's just do if buff 0 does not equal let's just do 1. And I probably don't need my hellos anymore, but whatever. Right. So I guess this is press and hold and release. So if I, okay, so top row is going to be 3, 4. Oh no, here we go. Q is 71. Let's start at A. A is 61. B, C, D. Okay. So let me pull up an ASCII chart because I can never remember. ASCII table. A is 65. A 65? A 61. Why are you off by 4? Decimal 61 equal sign. It's probably like a row and column number. Okay, let's go back here, and instead of having my delays and my configuration, and if we got something, let's do a match. What was by 1? Match buff or resp 0. Let's see. You are press and hold. Possible key states. Okay. So I guess we read a 0 key state, then that means that we've gotten junk. Junk. This is press hold release. Hero state, bad state. What did I do wrong? else break? sbuff as stir. Maybe I'm just absolutely slamming it and it's not happy about it. Reset. What are you connected to? Else, continue. That's actually probably what it is. I've probably fallen off the rails and it's probably panicked because it's hit the end. Which, yeah, I don't, result, you're supposed to return. Huh, interesting. Where are you? You are a loop. Oh, it goes to the loop. Huh. So no, that actually should be fine. If that's okay, then we get this, we print the status. Cool. Yeah, apparently I was probably just trying to query it immediately after it woke up, and it probably was not happy about that. Let's see if well, let's not even. Okay, so A, B, C, D. Is that ASCII table right? Because it says that A should be like 65. And instead we're getting 61. What happens if I do Shift A? I get 41. Capital A. Oh, hex. Right. Okay. So what if I do from um, um. One as UT. What is a slice? Rust. Stir from UTF-8. Core stir from UTF-8. Hey. WASD. Enter, 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 enter. $. Symbol at. P. Symbol. Oh, no, probably alt at. Okay, yeah. ASDF. Cool. So I have QWERTY. I don't know how to do shift lock. Alt shift. Oh, that seems to have broken everything. Huh. Interesting. Oh, it's probably because that turns on numlock, and I don't handle numlock. Interesting. Low. So what if I make you just a keyboard where where we just do press. Press, press, press. Hello. Hello, stream. That's interesting. I can go backwards. And then if I enter. Hello. That is a nifty little keyboard. I can do WASD. What happens if I hit volume up? Okay, apparently that is a back tick. Oh no. My enter is well, hold on, I can go back. Okay, this is pretty fun. This is typing on the BlackBerry Q Alt 10 with Rust. Cool. Well, got this all wired up here. So yeah, when I come up here and press keys and stuff like that, you can see it comes up on the stream. Well, no, you can't because it's over behind my face. Here we go. So when I press stuff and press enter, and I still have to hit backspace because I'm not actually totally emulating a terminal, and also holding down the key doesn't make it do it for forever. Backspace. So I can type. Cool. That works. I'm gonna try one more thing. I'm going to make it cycle through the backlight colors. Or not colors, because there's no colors, unfortunately. I'm gonna make it cycle through the backlight values. So let's have let mut backlight U8 equals let's start with 250. Backlight dot wrapping add 10. Backlight equals backlight wrapping add 10, and let's do Q10 what do we want? We want backlight. I guess this is a read. Boop, boop, boop. Are you going to make me do 2 writes? Do I have keyboard backlight, set backlight, write register, begin transmission write. Okay, so it just writes 2. Let's have write let's just give it a U8, that's fine. Out 1 equals write. And up here, let's do and mut twim. The register is gonna be 5. OX05, and backlight is the value that we're gonna unwrap. So now it should cycle through the backlight values. So this is working. I don't actually see, because it should be looping every 100 milliseconds. Which means like every second it should be kind of freaking out, but let's start at 0. And let's just steal one of you. So it should be going up. And up. Doesn't appear to be a lot brighter. There's kind of like a light under the microphone. It should have just dropped way back down, but it does not seem to have dropped way back down. So I don't know what's up with the backlight. Backlight control register. Index 5. 1 byte in size. Default value FF. And in his Arduino, he write register, data equals 2, register write mask. Right, you have to offset the registers by 8. Reg OX80. I remember reading that. I read the docs. Cool. Yep. Now we got a very fadey blacklight. I don't know if you can actually see this. I'll hold it way up here. You get a lot of light from the monitor. Let's make it go faster. Let's put my wrapping at 10 so it kind of freaks out every second. Let's see if this is visible. I think that's kind of visible. Yeah, it's not very in focus, but you can at least see it kind of. Let's see if I turn. Let's turn the light off a little bit. Looks better here than it does there. Very smooth. Okay, well, it is late here. It's about 1:30 in the morning, so that's a good proof of concept. I think on the next stream, now that I have some like very hacky but working code, I'm gonna do something like I did with the Otter Pill, and I'm gonna build out a embedded HAL capable driver out of that. So now I've got my feet under me, sorted out a development environment for this as well. But yeah, I hope you enjoyed. That was pleasantly successful after a little bit of struggle. So I probably won't put this anywhere because it's not super useful. It's mostly just me playing around and figuring out the actual protocol. Next time I'll kind of start from scratch, and I'm going to switch everything over to using the embedded HAL traits. Make a usable, good interfaced embedded HAL driver for this. Then I'll put that up on crates.io. So thanks for watching. If this seemed, or I don't know, check out Arturo stuff. Arturo's pretty awesome. So and I'm looking forward. He's making a Featherwing board that looks like a whole BlackBerry. So it's got one of those keyboards at the bottom, it's got a screen on the front, and it's got a like a feather wing socket on the back of it. And I'm very excited. And the reason that I'm actually writing this in the NRF52 is because I eventually want to take, this is an Adafruit NRF 52840 feather. And I want to write some software for that because I want to have a bare metal little wireless device with a keyboard and a screen. So hopefully more of that when I have that. But Arturo, you should ship that board. Well, I shouldn't harass other people about side projects because I take forever to do my side project. So I will continue waiting very patiently for Arturo to ship that. But I'm very, very excited for it. So thank you to everyone who watched. Yeah, I'll follow up probably sometime later this week and make an embedded HAL driver for this. All right, have a good evening.